Let's go through Leaker 1981. Minimize the difference between target and choosing element. Give us a two-dimensional remat and integer target. So for this match, each row we need to choose value and sum all of these values. And we want the sum and the target, the absolute value difference to be minimal. Return the minimal differences. Let's look at example one. If we choose 1 from row 1, 5 from row 2, and 7 from row 3, and the target is 13 and the sum is 13, so the difference is 0, so return 0. Um, Here, the m and n are small equal to 70, and this number is small equal to 70, and this target is small equal to 800. So, if we can thinking about we trying to generate all of the possible numbers for each row, we can use a set to dedupe. For example, if we have the first row, we have the number 1, 2, 3, right? And the second row, it may have 1 plus 4. Or that will be 5, right? 1 plus 5 will be 6, 1 plus 6 will be 7, or 2 plus 4 will be 6, right? We did you have 6, 2 plus 5 will be 7, 2 plus 8, 6 will be 8, and 3, 7, 9, right? It will generate to be 5 numbers for second row, right? And then the third row, we do this again, right? Trying to see what's the possibility. And then in the end, we look at the possible numbers, compare with the target, find the absolute difference minimal. But we can use a set. Of course, every row we use a set to dedupe. But doing like this, there is a problem. That is because of course, we have n multiplied by n, and for each row, it will be multiplied by the possible of the counts, right? Possible counts. So we'll see the second row, it will multiply by 3. And the third row will already multiply, I'm gonna go to 5 or 6, right? And then if these possible counts, it will be increase a lot. So let's say if this is what's the data range is 70, right? 70. So after 70 rows, this possible counts, it is possible it will maybe come into 4,900 something, right? So if we have m multiplied by possibility, that is 70 multiplied by 70, right? This will be TRE. So we should do some trim operations. Here there are two things, right? The first thing is that if for each row the minimal number, we sum the minimal number is already greater than target. That means the minimal difference will be the minimal sum minus target. Oh, and also, if the max sum is smaller than target, right? We just return the targeting minus max sum. So this is the first case, second case. So in the next case, that is the sum of this matrix can only the min sum and max sum have the overlap, right? Min sum and max sum have the overlap with target, right? So the target is between min sum and max sum. So instead of we use a set for each row, can we use a set to trim those kind of number, which just fall in some kind of ranges. So what does this mean is that, we'll see if we find for the possibility this number, right, it is already greater than some number. Then in the next time when it added, it will be greater again, right? So if there is some kind of limit, this number already being greater um this one, we should not count anymore. So let's find this limit, right? So this limit will be 2 multiplied by target plus 1, okay? So what does this mean? Is that if we already sum a number greater than this, and because the all of number is positive, so the number will be always greater than 2 multiplied by target plus 1, right? So in the end, we'll say in the end the sum will always be greater than 2 multiplied by target plus 1. And these 2 plus target plus 1 minus target, right, will greater equal to target plus 1, right? And I will say if we have the mean is smaller than target and max greater than target, right? We apparently there is some following in the between, right? So we'll see the sum following in the between will be smaller than that the absolute difference was smaller equal to target, right? So that means if in the middle of the part we already have some the greater than 2 multiplied by target minus 1, we don't need to calculate them more, right? So we do a trim. So only when the number is smaller than this one, we add to a set, right? Instead of use set, we can also use a Boolean array to deduce. So doing like this, we can have we only check those numbers smaller equal to 2 multiple target, right? So the time complexity will be m, and the possibility is 2 multiple by 2 target will be 70 multiplied by 70 multiplied by 1060. So it will be passed, right? So let's write code for this. So let's have int min sum equals 0, max sum equals 0, and m equals mat dot length, n equals mat 0 dot length for every row in mat. So we find the max value in the mean value for each row, right? In mean equals so mean because the number should small equal to 70, right? Let's initially set as 70 and max in set as 1. Okay, so what we do is for every interval in row, mean equals max dot mean in the v, right? And the max equals max dot max in the v, right? So we'll see mean sum should plus equal to mean, and max sum should plus equal to mean max, right? So we'll say if this mean sum is greater than target, we just need to return mean sum minus target. And if max sum is smaller than target, then we'll just return target minus max sum, right? So after we go into this line 19. So that the sum is in the range. Uh, the sum is in the range of 0 to 2 multiple by target, right? So when we calculate, we just need to the maximum will be 2 multiple by target. So we can open a Boolean array to target plus 1, right? So if we come here, we didn't terminate for this two if, that means our sum, we just need to use this Boolean um, exists, right, or whatever dp exists, or equals new Boolean. Let's say the maximum or 2 multiplied by target. So let's set this one as 2 multiplied by plus 1, right? So for initially for v into v in math 0, we're going to have if this v is smaller than 2 multiplied by target, right? Because we just need to check in this kind of range. But this v it is possible v is greater than target, right? So just exists v equals true. Then what we do is that for the row, right, into I equals 1, I smaller than m, I plus plus. We check for next row, what what's a possibility, right? So this possibility, we just need to check 2 multiple by target plus 1. We don't need to check the data greater than this limit, right? So what we do is that we're going to have Boolean new exist equals new Boolean 2 multiple by target plus 1. Then what we do is that for int j equals 0, j is smaller than n, j plus plus, we're going to have for int k equals 0, k smaller than 2 multiplied by target plus 1, k plus plus, right? So if dp mat, not say dp exists, mat I j, right? We actually want this k plus v is smaller than this range, right? So we don't even need to. We need to have this one to, let's say this is v, right? Int v equals this one. So for this k plus v is smaller or equal to this. So we'll say if dp k, right? Then we're going to have dp k plus v equals 2. So we'll say dp k plus v should all equal to dp k, right? And in the end, let's set not dp, sorry, this is new dp, right? New exists. This is exist. Exists. And this new exists. And after this, we we are going to have exists equals new equals this. Right. So we find the minimal differences. Int result equals integer dot max value, right? Then what we do is for int I equals 0, I smaller than 2 multiply target plus 1. Of course, if there is absolute, right, you can also have I smaller than target or I greater than target, right? But let's get this one simple, just write this. If exists I, then result equals max dot mean result max that's the value I minus target. Right? So in the end, just return result. As we talk about, this will be OM multiplied by target time complexity. Um, so let's also write Python code for this. M n equals length of mat and length of mat 0. So we have min sum max sum equals 0, 0, right? For row in mat, min sum should plus equal to min row and the max sum should plus equal to max row. And then we'll write if min sum is greater than target, return min sum minus target. If max sum is smaller than target, return max sum minus target. And then in this case, that means min sum and the max sum, the difference is the target is in a range of min sum and max sum, right? And the difference is well the will be within the target, right? Um, so then let's say we can have and for example limit equals 2 multiplied target plus 1, right? So we are going to have exists equals false multiplied limit. So for v in mat 0, we're going to have if v is smaller than limit, then we'll have exists v equals true. Then we go through each row, right? For I in range from the row 1 to M, right? So we have new exists equals false multiplied by limit. Then what we do is for v in mat I, we're going to have for um k in range limit minus v, right? So if dp k, then we're going to have dp. So we'll say dp k plus v, right? dp k plus v is all equal to dp k. Then we'll have not dp, new exist, right? Then what we do is we'll have exists equals new exists. So after going through this, let's get a result equals float IF n for I in range limit. So if dp if this is exists, right? So if exists, right? Then we'll have result equals mean result absolute value I minus target. So in the end, just a return result. Target mean absolute value I minus target result in range limit mean. Why there is a negative number here? Here, right? Because we terminate. This is target minus max sum of